using Python. Uh, Let me give you a short intro based on logistic regression. So let me share my screen. Whether the screen is visible to everyone?
Yes, ma'am.
Okay, thank you.
Yes, visible, ma'am.
Okay, thank you so much. So, as I was telling, let me give you a brief intro about the logistic regression before we start on proceeding on how to perform logistic regression using Python. The term logistic regression is a statistical method which is used to analyze the relationship between a binary dependent variable and one or more independent variables. So, whenever we say the term relationship, we always get a dependent variable and an independent variable. So here, for the logistic regression case, the binary dependent variable will be the dependent variable will be a binary one, and it may have one or more independent variables. The dependent variable in logistic regression is binary. That means it can take only two values, 0 and 1. The independent variable can be continuous, categorical, or a combination of both. Now, you may ask me, like, why you are performing a logistic regression? Why the course are necessary? Why the necessity of logistic regression is there? Because the goal of logistic regression is to find the best fitting model that predicts the probability of a given outcome based on the values of the independent variables. The logistic regression model, it uses a logistic function which is used to map the input values to the output probability. The logistic function, if you see the curve, it will be a S-shaped curve that starts at 0 and ends at 1, which is representing the range of possible probabilities. Because we know the probability values lie between 0 and 1. Now, in binary classification, the outcome is a binary response, such as yes or no, male or female, to do or not to do. Now we have here the simple regression model. Y is equal to beta naught plus beta 1x plus epsilon. So, you know what are the interpretation of this particular terms. I'm not going to the theoretical details. Now, I'm telling you what we can do with this model. We can build a model to predict house prices. Now, the house prices here will be the dependent variable based on different independent variables such as districts, units, or distance. Now, this same idea cannot be applied to binary classification problem. Okay, let me give you another example. Suppose we want to predict if a house is sold based on its price. So, a model based on linear regression will be sold is equal to beta naught plus beta 1 into price plus epsilon 1. Now, here sold is equal to 1. The value of sold is equal to 1 if the house is sold. And sold is equal to 0 if it was not sold. So, you can see here the binary response is there. So, the house is sold and the house is not sold. By performing visualization also using linear regression, we can draw a line of best fit to the data point. Suppose we want to see if the price increases, the chance of selling a house will increase or decrease. So if you are given a particular type of data, from this we can see if the price of the house increases, then the selling of the house decreases. Now, instead of considering the previous equation, okay, that what was the equation? It was sold is equal to beta naught plus beta 1 into price plus epsilon 1. Now, instead of considering this equation, we will be considering the probability of sold is equal to beta naught plus beta 1 into price plus epsilon. Now, why probability because we don't know what is the chance of selling a house, whether the house will be sold or not. So we are attaching the probability here. Probability of sold is the probability of selling a house. And we know the probability value will be between 0 and 1. And what is the midpoint between 0 and 1? It is 0.5. And what is 0.5 representing? That the chance of selling a house is equal to the probability of not selling a house. Now, when the price of a house is very high, then the value of probability of sold can be negative. Okay, but we know that this probability term cannot be negative because it lies between 0 and 1. So, what to do in this situation? We can instead use this particular model in this following situation. That is, we can take the ratio P by 1 minus P, which is equal to beta naught plus beta 1 into price plus the epsilon term. What is P here? Here P is the probability of selling a house. And what is 1 minus P? 1 minus P is the probability of not selling a house. Now, the range of the ratio P by 1 minus P is in the range 0 to infinity. And if you consider that if the value of P is equal to 0.5, then the ratio P by 1 minus P will be equal to 1. Just if you do a rough calculation, you take the value of P, 1 minus P is 1 minus 0.5, that is also it is equal to 0.5. So 0.5 cancels, it is equal to 1. So if the range is equal to 1. Now this ratio, P by 1 minus P, is called as the odds ratio. Now, to interpret the odds ratio, how can we interpret? Like P by 1 minus P is equal to 1. What we understand by this particular term? So that is, for every house that is sold, there is a house that is not sold. Okay. The ratio P by 1 minus P, when the value is equal to 1, we can interpret this in this particular way. That is, for every house that is sold, there is a house that is not sold. And when we take the value of this P is equal to 0.75, then the odds ratio is equal to 3. That is, in the right hand side, if you take the value of P to be 0.75, then in the right hand side, you will get to see that it has become 3. So in this case, the interpretation will be in this manner, that the odds of being able to sell the house are 3 times higher than the odds of not being able to sell the house. Now, if you're going to the second equation, what we have done, what was your epsilon 2, if you consider this equation, then the odds ratio is 0 to infinity. But what was our first equation? Our first equation was simply a linear regression equation, where y is equal to beta naught plus beta 1 into price plus epsilon. That is, when the price of a house is really high, then the estimates of the odds ratio could be negative, which contradicts the probability property. Now, in addition, because this midpoint is 1, but the odds ratio is from 0 to infinity, then the distribution is very skewed with a long right tail. Now, in the assumptions of linear regression, we expected that it should be normally distributed. So instead of using the second equation, we will be using this particular equation. That is, you will not only take, it was our second equation. You just see P by 1 minus P is equal to beta naught plus beta 1 into price plus epsilon 2. So if we consider it to be the second equation. So instead of using this equation, if you take the logarithmic of the odds ratio, that is log of P by 1 minus P is equal to beta naught plus beta 1 into price plus epsilon. Then this value, log of P by 1 minus P, is in the range minus infinity to infinity, and the midpoint is 0. So we can now tackle this particular situation when the value becomes negative, because now the range is between not from 0 to infinity, but in fact it becomes minus infinity to infinity. That is why we have not taken in the right left hand side P by 1 minus P. We have taken the logarithmic of P by 1 minus P, so that the range will be from minus infinity to infinity and the midpoint will be 0. So similar to linear regression, we can use the following formula, log of odds. Now what is our odds here? our odds here is p by 1 minus p, which is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus how many variables we consider. So we can, what we can do with this equation, we can use this to interpret how the explanatory variables are associated with the categorical outcome. Because here the dependent variable is 0 and 1, and x1, x2 may be a categorical variables. So I will not be going further into the theoretical aspects of logical regression. I will be now shifting on to the how to perform logistic regression in Python. I think you might have understood the short theoretical description what we have. Yes, whether I'm clear?
Yes, ma'am.
Okay. So you all have Python loaded, that is Jupyter and all loaded in your laptops.
Yes, ma'am.
Okay, because Jupyter, it will be easy because we will be importing some packages. Okay, so it will be like if we can do with PyCharm and all different other platforms are also available, but here we will be using Jupyter because the importing like the always the internet is connected with this, and it will be help us in the importing of the libraries. Okay, different library packages. So now let me go into the data with which we will be performing the logistic regression in Python. So here the data that we have considered comes from the accident and explosion of Space Shuttle Challenger in 1986. Now on January 28, 1986, the space shuttle lifted off from Florida. Shortly into the flight, the shuttle exploded, and all the crew members were lost in the tragedy. A follow-up investigation revealed that the zero rings on the shuttle boosters that are designed to keep the fuel from sitting out of the booster failed, allowing fuel to ignite and cause the disaster. Okay. So presumably the zero ring expanded due to the temperature. Now one variable here is temperature. And you can see from the question that another variable here is zero rings. At temperature at which the shuttle was launched, which was at PG 31 degrees, much colder than any previous launch. The cold temperature apparently caused the zero rings to expand, allowing fuel to leak off into the main booster, causing the explosion. So now I think you all have got the course, what I have given you 15 or 20 minutes back in your mail.
Yes, ma'am.
Okay, so we will please open your platform where you will be doing Python and copy this first course, so it will be easy for both for you also and for me to discuss on the code. So we can perform it together, and one by one we can run.
Excuse me, ma'am. I had a query regarding this installation thing.
Yes.
Do we need to download first Anaconda and then only we can use this Jupyter and then download Jupyter, or Jupyter Notepad can be separately
No,
downloaded?
Jupyter Notepad is sufficient.
Okay,
Because
we do not need.
Anaconda, you will be getting different. Spider also will be there. PyCharm also will be there. You need only the Jupyter. So the Jupyter will be sufficient.
Okay, okay, fine. Thank you, ma'am.
So can we move on with the session?
Yeah, sure, ma'am.
Yes, ma'am.
So what we were discussing that we have the course here, and the course are we need to import. As I have told you, we need to import the different libraries, okay, which are related to solve this particular problem. Now, that is why we are using this Jupyter. Now, the following what you can say, should I make it the size should be a little big, or it is okay? You can view it easily, or should I maximize it a bit? Yes, are you getting me? Should I maximize the size, or whether it is okay?
Yes, madam. Should be maximized.
I should be maximized. Okay. It's okay now?
Yes, ma'am.
Okay.
Okay, okay.
Yes, it is okay now, madam.
Now you can see this is the challenges data. Okay, 0, 1, up till how many we have? Up till 22. And as I have told you, there are two variables, zeroing and temperature. TMP is a short form of temperature we have written here. So these are the measurements as to whether or not there was any blow-by that was recorded as a failure. Okay. Now, a blow-by is crudely defined as, we were not defining what is blow-by, but because we are basing the term 0 and 1, so I'm defining the term what we mean by blow-by. So blow-by is crudely defined as gases sitting beyond the seal of the booster. So this 1, here the term value 1, it is denoted as a failure. That is, there is blow-by. Okay. And while 0 is denoted as no failure. So when there is failure, it is denoted by 1. And when there is no failure, it is denoted by 0. The temperature variable, here it is TMP, it is in degrees Fahrenheit. So we build this data frame in Python. We need to fill this data frame in Python. So what we can do, we need to import pandas as PD. Now, why we need to import pandas as PD? Because we need to use functions for working with data values. Now, we also need this particular pandas library to use other essential utilities like aggregate functions and rolling functions. Okay, that is why this particular library is imported from Python. Import pandas as PD. Now, as we have seen that there were two variables, O-ring and temperature. So we need to shape it in the form of a table. Okay, so data is equal to 0 ring 1 1 1 1. How many values are there? That is consisting of failures and no failures. And the temperature values, the recorded temperature values are also noted down. Okay, now this left hand side you need not worry because it is only the naming variable. You can give any name. Okay, there are certain naming rules how you should be defining the variable names in Python. So you can see any books related to Python and can see how the variable named. But we are interested in the right hand side. So right hand side ed dot data frame. So data is this what we have written over here. Now, what is ed dot data frame? It is a two-dimensional data structure. That is, data is aligned in a tabular fashion in rows and columns. Pandas data frame consists of three principal components: the data, rows, and columns. Okay. So clear with this particular code, then so now we need to see what are the values. Okay, how it has been shaped in data frame. So if you just simply type print and the variable name df challenger, then we can see this in the output file. Okay. Now let me take the other course. Okay. This particular code you just copy and paste it over here and run it. Yes.
Okay, why we need to enter pandas?
Because we need to use functions of working with data values. Okay, date values. So we need to import pandas, and we also need this particular library to use other different functions like rolling functions is there, the aggregate functions is there. So we need to import pandas. Yeah. Yes, whether it is
And
clear.
is it like, ma'am, is it like installing packages, like the different within?
Yes, yes. Like if you have done art, we are installing
Yeah, yeah,
package
yeah,
libraries. Okay, from art.
yeah,
Let's
yeah.
suppose to do Bayesian, we need to import the install the Bayesian package. Okay, to do any time series related analysis, you need to import the T series package. So for this, we need the Panda package.
Okay,
Yeah.
okay, okay, fine.
Okay. So you can see here df underscore challenger o-ring. So it was our value underscore count, then first bracket start, first bracket close. Now after this part, because it will be counting how many one values, because we are not interested with the temperature values here, because now we are interested with the binary response. So that is how many failure cases were there and how many no failure cases were there. So that is why only we are using this particular O-ring, zero ring. So this term value underscore count, what does it do is that it is a method which returns a series containing the counts of unique values. So what are the unique values here? The unique values here are 0 and 1. That is, it will be counting. Okay, how many terms with 0 are there? How many terms containing 1 is there? This means for any column in a data frame, this method returns the count of unique entries in that column. Okay, that means you can see a total of 16 booster successes. Here you can see 16 booster successes and 7 times the booster fail, because we have considered fail and no failure. Okay, so 16 booster successes we got and 7 times the booster fail. That is, in this data set, 16 times there was no event of slippage or blow by, and 7 times there was. Okay, so the terms, how many terms there was failure, how many times there were no failures, we can use this particular value underscore counts and can see how many terms the failure event was there and no failure event was there. So clear with this particular term code.
Yes,
If,
ma'am.
yes, if it is clear, then let me take this. We are going a bit slow, okay, because we need to understand the code slowly. So please copy this to code and run it. Now, because why we are doing this particular, taking the help of this particular course is because a plot will always allow us to visualize the distribution of counts. Okay, like what are how many times zeros are there. By visualizing only, you can see. We no need to see the numbers. How many numbers are there? No need to see the table. Just a graph will give us a clear picture of count. Okay, so for this we are using the Seaborn package. So it is another package. Import Seaborn as S and S. So what does this mean? The import Seaborn portion of the code, that is this particular code, the import Seaborn up till this part, okay? This portion of the code tells Python to bring the Seaborn library into your current environment. Okay, and after this, these two terms, AS, S, and S. What does this do? This portion of the code then tells Python to give Seaborn the alias of SNS. That is, every time now I will be using the Seaborn package, I can simply write S and S. Okay, no need to write in full Seaborn. I can simply I can simply write as SNS. Now, this allows you to use Seaborn functions by simply typing SNS.function name. Okay. Now, Python Seaborn library, this Seaborn library, it is a widely popular data visualization library that is commonly used for data science and machine learning tasks. Also, using this particular library, you can create interactive plots to answer questions about your data. The Seaborn library SNS, okay, in alias we write it as SNS. So this the Seaborn library was named after a character. It was Samuel Norman Seaborn. Okay. So after it is named the alias SNS, Samuel Norman Seaborn. So from his character name Samuel Norman Seaborn, the standard alias is the character's initial. So from this we have got this particular term SNS. So we have understood the particular meaning of this line code. Now let us go to the second line. That is SNS dot count plot. Now, what does this do? This Seaborn dot count plot, it is a method which is used to show the count of observation in each categorical being using bars. So count, they are showing the count. Only count means what? How many times this number has occurred? How many times this number has occurred? Okay, in beans. So you can see here is one bean containing of term 0, and here is another bean containing of term 1. So you can see here 16, and here also in a tabular form you have got the how many times the term 0 has occurred, 16. How many times 1? It is 7. Okay, so in a visualization, if you plot it also, you will be getting the same thing. Okay, but we can understand visually without the going going into the tabular form. Clear with this particular code? Till now, we have not gone to the details of the logistic regression. We are coming step by step. Okay. Now, after this, what you have, you just copy this particular code and paste it in your Jupyter platform and run it. Okay, now let me first explain you what does this particular thing mean. Now, there are a few ways of computing logistic regression in Python. Okay, many ways are there. If you see the YouTube of performing logistic regression in Python, you can see there are as many ways of performing logistic regression in Python. Now, here you are using the step models. sklearn is also it can be used, but for this problem we are using the term stats model. So here we have done, you have to we have to import this particular package, import stat model. So what is the function of this package? This stat model, it is a Python module that provides classes and functions for the estimation of many different statistical models, as well as for conducting statistical tests and statistical data exploration. The results are tested against existing statistical package to ensure that they are correct. That is, if there are different statistical tests, okay, we need to perform, like t-test, the value of what is the p-value and all. So for this, we need this particular package stat model. So we have to import the stat models library, only then it will this values we can get, okay, and then we can interpret according to our data what we have. After this, you can see stat models dot API SSN. Now the main stat models API is split into different models. Okay. Now there are stat models dot API. There is stat models dot TSA dot API. Also stat models dot formula dot API. But here we will be concentrated only on stat models dot API. Now this cross-sectional model and methods it is based on. Canonical imported using stat models can also be done as SL. Now this term API, okay, you can see dot API. This API focuses on models and the most frequently used statistical tests and tools. Now they import parts and structures, explain the design of the two different API modules, and how importing from the API differs from directly importing from the module where the model is defined. Okay. So for this, we need the import stack models dot API SSN. Now you can see we will add a constant. First, we will add a constant because because only with this particular code add underscore constant x. But before, let us define what is y. Now our y vector is equal to the zeroing variable. This is equal to our zeroing variable. It is consisting of the values of zeros and one. Now what is x? X is the value which was having the values of temperature. So we have replaced the name of temperature with x. Okay, remember this because later on during the interpretation part we will be needing this. Okay, that is now the temperature values are replaced with x. Okay, that is I will not be telling now temp. It is equal to x. And x underscore constant is another variable name which is adding the constant x here. So we now, what we do now is that we now specify our model as follows, and we will be requesting model fit statistics through different codes. So let us see how this can be done. So let us copy this particular code. Okay, have you got this particular code?
Yes, ma'am.
Okay. Now you can see the first code model is our naming. Okay, so we are not interested with this part. We are interested in the right hand side. This sm dot logic function takes two arguments: the dependent variable y and the independent variable x. Okay. Now we also add a constant. We can see to the independent variable using the add constant code, which is required for the logistic regression model. Now, what are these sm.logic values? These are the values that are calculated by the stat models library during the fitting of a logistic regression model. Okay, so this term, because logic, if you remember, log of p by 1 minus 2, we have taken the logarithmic of the odds ratios. Okay, so logic. The sm dot logic values, again I am repeating this. Why are they added here? They are coded here because they are calculated by the stat models library. From this library, during why we need to fit a logistic regression model, and what they provide us information about the model's coefficients, about the standard errors, about the z scores and p value. This all you can see in the output. Okay, we will be discussing it a bit later. Now, understanding these values is important for interpreting the results of a logistic regression, because all the values are in the output file, but the interpretation is also very important. Now, you can see in the, so I think by now this particular code why we need is clear to you. Now, next come to the second line of this particular para. So it is model.fit. Okay. So why we need it for supervised learning application? This accept two arguments: the data x and the levels. Okay. And for unsupervised learning application, this accepts only a single argument. So here we are concentrated with two arguments. This logistic regression, what we are doing, it is sometimes called the logistic model or logic model. And why it is used? It is used for predicting the probability of occurrence of a specified event by fitting data to a logistic function card. Okay, so I think, and how can we see the only the model fitting is not important, but here this summary will give out a detailed description of all that you need. Okay, that what we need, you need the pseudo score value. What you need the p value. What you need the z value and all. So this summary of the results will be you will be getting by this particular code results.summary, then the parenthesis. So,
Ma'am, I have one query.
yes,
Why we should put why in the first place in the model?
because see, why here it is our, how many terms zeros were there, how many terms one are there. Okay, so we have put it y. And sm dot add constant because we need to add this values. Okay, the intercept line, otherwise you will be not getting. You will be only getting the as a straight line. Okay, so that is why we to add the intercept we need this particular code add underscore constant, then the x variable. What is the variable x here? The variable x is our temperature value which we had in our data set. Okay. Now, if you have the output file with you, so see the output file, and because any software will be giving you the result, you can perform logistic regression with the help of SPSS, in R, and in different others. Okay, but the interpretation of the results are very important. So all of you will be getting this output file. So how can you interpret from this particular output file? So the intercept of the regression equation here, it is equal to C. What is the intercept value? Can you tell me what is the intercept value here?
15.0429.
Yeah, 15.04. So, and the temperature estimate, what is the value?
Minus 0.2322.
Yes, minus 0.2322. And we have the pseudo R square value here to 0.2813. Why the term pseudo is used here? It is used here, which implies the statistic should not be interpreted one-to-one with a traditional R square value. Okay, we are not using a traditional R square. You can in fact go to the details of the pseudo R square going to any theoretical literature, but here only R square is not calculated. Pseudo R square is calculated. Okay. As one would have in an ordinary list square. In an ordinary list square, simply you will be getting the R square value. But in this logistic regression case, you will be getting the pseudo R square value. Now, we can see that temperature
Ma'am,
is
is it similar
statistically.
to adjusted R square? Pseudo R square is similar to adjusted R square,
Yes,
or
yes.
is pseudo R square similar to adjusted R square?
I cannot get it.
Pseudo R square similar to adjusted R square.
Yes, in ordinary list square, it will be getting only R square. But here, the variance will be somewhat different. Okay. Can be used as the effect of size for the model. So in logistic regression, we are using pseudo R square. Not
Then
only
we
the
get one normal ordinary R square, and then we have this adjusted R square. Actually,
R
when we do
square.
it,
Yes, yes,
adjusted. One is
Yes.
normal R square, and one is adjusted R
yes.
square.
Adjusted R square.
Yeah, so it is similar to that pseudo R square.
It is similar to that. Yes.
Okay.
Now, also from the table, what we can see that temperature is statistically significant. So, statistically significant from which value you can predict? If I tell you the temperature is statistically significant. So, you can see here the values of temperatures are there. Statistical value is related to P. Okay. So, here the value of P is 0.032. So, that means the temperature is statistically significant. Now, we can write our model equation. So, what was our model equation? How you write it? Y equal to the intercept and the plus the your variable. Okay. So, what is the intercept here? How will you write it? Now here is my predicted logic. Okay. So, predicted logic will be equal to your 15.0429 minus 0.2322 into within bracket temperature. Clear? So this will be your estimated equation for predicting the response variable, which is in this case logic. Okay. So let me show you how we can write our this See, I was telling of this particular line. Predicted logic will be equal to, see, we have here 15.0429, we have 0.2322, and also we have the value of 0.032. So we can write here predicted logic is equal to 15.0429, then minus 0.232 within bracket temperature. Now, the response variable here is the log odds. Okay, because we are taking the logarithmic of the values, that is the logic, and are not naturally occurring originally variable, because when we started with on with logistic regression, the values were only binary variables 0 and 1, but now they are log odds. Okay, log within bracket p by 1 minus p. So we have these values with us. Now, let us use the equation to predict some logics for different values of temperature. Now, you can see, if you see earlier, these are the different values of temperature. So, for first value, you have this particular equation with you. That is, this predicted logic is equal to 15.0429, then temperature. So, what is our first value here? Our first value here is 53. So, multiply with this, then you will be getting the predicted logic of the first value of temperature. And how you can calculate the other logic values? Simply you yes. So for the first value of temperature, see, our first value of temperature is 53. Okay. Now, if you put this in this equation, 0.23, we write our predicted logic is equal to, as I was telling you, it is 15.0429 minus 0.23. Why minus? Because here we have got the value in negative. Okay, minus in terms of minus. So here it is minus 0.232 into what is the temperature first value? It is 53. So we will be getting the value as 2.7363. Similarly, for the second one, you can see what is our second value here. You see our second value here is 57. So in place of x, you just write 57 and you can see the value comes out to be 1.8075. So for the whole data set, if I want to calculate the predicted logic, and I write the this form, because now what is our x? Our x is representing the temperature value. Okay, so just if first I have to write this particular equation. Okay, then if I simply write the variable name, then it will be giving me the whole predicted value list containing all the temperature values. Okay, now from these values you see, yes, see what happens. We are going from positive numbers towards 0. You can see positive numbers, the numbers are decreasing. Okay, 2, 1, 1.80, 1.57, then they are decreasing, and then increasingly into negative numbers. See, then they are increasing into negative numbers. Now, what is the reason behind this? It is because our temperature data follows a similar trajectory for smaller values of temperature to larger. See, our temperature values, you can see, they started with smaller values, 53, 57, 58, 67, and then it proceeded to 81. That is from smaller to larger. So here we are getting this value because of this pattern. It is because of this following pattern. Because from smaller values of temperature to larger values we are getting. So we will be getting the predicted logic first positively decreasing, then moving towards 0, then increasingly into negative numbers of greater absolute magnitude. Okay, so this was on logistic regression. Now, a Spearman row should detect what is the monotonicity. Okay, in a model, and this will be calculated from the correlation value. Value we will be getting either +1 or -1. So how you can do it in Python? Let us see. So here we have another code. You also have with you. So from this, you take this two and just paste it over here and run it. Sorry, I have pasted the similar thing. It was just so here we can see first. Let us understand why we need to import the SkyP import step. Okay, so all of the statistical functions are located in the sub package SkyP.steps. SkyP.steps. And a fairly complete list of this function can be using the info steps. Okay, so you can see in your free time and can see what are the different statistical things you can do. And the list of random variables can also be obtained from this particular sub package. The next, so what you can see from here is that we obtain the correlation value as -1. Okay. Now here the p value is irrelevant. Why? Because we simply wanted to demonstrate as values of temperature decreases, values of the logic increases, and vice versa. That is why, because we wanted to check only this part. That is why only we are interested with the correlation value, whether it is negative or positive, or and vice versa. Okay, that is why we are not interested here with the p value. Only for checking this particular demonstration, that is, if values of the temperature decreases, then values of the logic increases. Vice versa, if values of the temperature increases, then values of the logic decreases. So because only wanted to check this particular relation, we have used, we need to only see the correlation value. And we have got the correlation as -1, which depicts the interpretation part. Now, a plot of this relationship clearly reveals, will be revealing the linear trend. Okay. So how to plot this relationship? Now, for this also we have certain codes. So you can see at last there are different codes. So you just copy these codes and paste it in your Jupyter platform. And run it. See, we have got. Now, before going into the description of the plot, let me explain you what are this particular codes used for. This import matplot library imports the pyplot module. Okay, imports this pyplot module from the matplot library and gives it the alias PLT. So after this, whenever you will be using this matplot library, only just writing the PLT will be enough. Okay, so that is why we have first hand we have written import matplot library.pyplot as PLT. Again, here we have written as import numpy as NP. Why? Because it should be at the beginning in our code. Okay, whenever we write it. Why? Because this will allow you to call functions from the library without needing to write out the entire name numpy each time. That is, if I write as NP, so if I use it again and again, we simply need to write NP. No need to write numpy every time, import numpy. Only NP will be sufficient. So that is why we are using. And why we are using the numpy package? It is used for working with arrays. It also has different functions for working in domains of linear algebra, Fourier transform, and matrices. Okay. NumPy was created by some person, I forgot the name. it is also a source, open source library, and it is under the head NumPy, and we write it, the alias is MC. Now this plot function, now you come to the third code, plot. Plot function. This plot function in PyPlot module of Matplot library, it is used to make a 2D hexagonal binding plots of points x and y. So here, what are the values? Here the values are written in terms of predicted logic and x. Okay. There is whenever we have an x and a y value, and if you want to plot it, then we can use this particular function plt.plot and within bracket x comma y. Then we will be getting a plot of the values x and y. Now the next one, plt.xlabel. Then here the predicted logic. That is, the predicted logic will be there in our x-axis. So what is the meaning of this particular function .xlabel? It is used to set the label for the x-axis. Okay. Similarly, we need to set the label for the y-axis. So we do it using the y-label code, plt.ylabel. So in the y-axis, we need to write tmp. So we write it as plt.ylabel. Now, for any heading is important. Okay, the graph also should have a title. So how we write the title? plt.title and temperature. So it will be coming in our function temperature as a function of logic. So we get this, and we have plotted the predicted logic values, and here our predicted logic values, and here are the temperature values. So you can see that as the values of the temperature decreases, values of the logic increases, and vice versa. So from the proper visualization of the plot will help you also to interpret the things in a easy manner. So all this was on binary logistic regression. Do you have any confusion regarding this?
Yes, me. I am not understanding why log logic increasing when temperature increasing, and in the starting uh, data, what is meaning by oring?
Oh, O-ring, let's see. Okay, let me go to my PPT and then you can visualize and see. O-ring is our variable name. Okay, suppose you want to write it as sex. So here, suppose we have used the term O-ring. You want to write it, another variable is whether sex is related to height. So height is my temperature. So this one of our variable naming, it was nothing else. So let me go to the data set. So see this data set here. Whenever we started with follow-up investigating revealed the zero ring. See, I'm also not a specialist in physics and all. This all are coming from the physics part. We have only taken an data from there. Okay, that is there. Some things happened in the explosion of in space, and all the few members were lost. So why? Because of a failure of this shuttle booster. So we are interested whether the shuttle booster, we have written it as 1, and if there is no failure, we have considered it to be 0. Okay. Zero ring, you forget it because it is not to do anything with Python. It is somewhat related to physics. You can, if you have any physics friend, I'm also not an expert. Zero ring, you can search it in the net also. Okay. Like when the explosion happened, maybe certain things are happening when it is called as the zero ring. So it is only the variable name. This part it is clear.
Yes, ma'am.
Now, which part you are having doubt?
Ma'am, in predicted logic, 0, 1, 2, 3, and -1, -2, -3. How?
Okay, let me go to this. Yes. Okay. This one. This one you wanted to know.
Out 11 line.
Yes.
The temperature as a function of logic diagram. The x-axis.
Yes. So what we have done here, we have only plotted the predicted logic values with the temperature values. Okay, it is our predicted logic we have calculated with the help of this formulas and the codes, and we have the X values from our data set. So just we have plotted the values and nothing else. This all temperature increases, decreases, because see, here we have with us the data in this way. All that is, it is in ascending order of magnitude. Okay, that is why you can see when we have calculated the predicted, because we are taking the logarithmic also. Okay, we are taking the logarithmic of the values here. So first values it is positive, next it will be decreasing, because your temperature values are increasing in ascending order. Okay, it is increasing. So that is why it will be decreasing in this case, in the predicted logic.
Thank you.
Any other question?
Okay, one question, madam. When we define the independent and dependent variables, here DF challenge is mentioned.
Yes.
So is it important to define every independent and dependent variables?
Yes. Yes, we have challenge there. I could not get your question. What you wanted to know?
Do we need to mention DF challenge for every when we
Like
define
what?
independent?
Suppose you mention here only data set. Okay, then everywhere you have to mention the term data set. Whatever name you are giving, you have to mention that particular name. It is not necessary that you have to mention DF underscore challenger everywhere. Now, suppose you have I have written it to be a DF challenger from the particular suppose I have. It is not my example. Okay, I have taken a help from a particular book and given you they have demonstrated it in Python. Okay, so they have taken the variable name. Now it is upon you what variable name you want to give. Suppose you have given the name as challenger, simply challenger, DF, not DF underscore. So it is enough. You can here what you have to write, print challenger then.
Okay, it is data set's name. It should be different, right?
Because data frame is there. Okay, data frame.
Okay.
Now,
okay.
Any question, anyone?
But then you have saved one data equals to also that. Like, how does it differ? Like, one is variable. O-ring means what I've understood is, ma'am, when there's a temperature 53, the failure is 1, right?
Yes,
57 failure 1. When it is 67, there's no failure. So that is how you have coded the O-ring with the temperature wise, and then you have kept it in the data variable.
Frame. Because if you remember what is the meaning of data frame, it is a two-dimensional arrangement of an array in rows and columns. Okay.
Okay.
So,
actually, DF challenger is a variable where you have put the values in an array.
Values, yes.
Yeah.
Where it is
and data frame is actually a function, right? Data frame
is
data frame is where you're calling where you're calling the data from the data is also a variable, ma'am.
Which one? Data frame. This
data frame is a function. It's a function.
Data frame is a function. It is a function.
Data is also a variable.
No, data is a part where we have included this data. Now, suppose we have data related to sex and height. Okay, you want to see whether there is any relation between sex and height. So, suppose 0 ring is replaced with sex and the temperature is related to height. So, you can write here any name. Okay, relation also you can write here. So, you can instead of writing data, you can use the term relation. Whatever
that I got, ma'am. We can put any name, whichever we want to. But what is it identified at? Is it identified as a variable? Is it identified?
Yes, it is an identifier. Like what is the identification of my data set? Now the my data is identified as data here. Now if I write, I can write here data 2 also, data 3 also. Now this, I am doing from my only from first data, so it is identified as data.
Okay. It's like accumulation of all my data set into one particular. Instead of
One
calling
particular,
every time
yeah.
11153,
Yes,
it's
yes.
better to
Now
keep it at
suppose
one.
if you have listened from the first starting of the session, we have I have told that there will be a dependent variable which is binary and one or more independent variables. So temperature is one of the independent variable here. Another variable may be there. Suppose humidity may be there. Rainfall may be there. Okay. So again, we will be giving a comma, and then we will be writing humidity HUM within the quotes. Okay, single quotes, and then colon, and then starting with the third brackets, we will be writing the values of humidity.
Okay, ma'am, one more question regarding this logistic regression. The dependent variable have to be necessarily in my binary form,
It
right?
is for
Yes
a
or no?
binary logistic regression. We have more the binary logistic regression also. So binary logistic regression dependent variable 2.
It has to be in either or answer, like yes, no,
Yes,
1,
yes,
0.
yes, no, yes, categorical.
And it could be like this also, my male, female,
Yes, male, female. I
or
have told
Hindu
you.
or other
Yes.
religions
What
like
to
that
do?
also.
Success, failure. Then this type you will getting binary response.
Okay. Okay.
Any more questions? Now, see, I will not.
Logic.
Yes.
Okay. Instead of logic regression model, shall we use the probit?
Yes, we can also use the probit. It is a different part, so I'm not going to that extent. We can do with probit.
Okay. 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 Fine.
Yes, I will be sharing with you after the class, this particular PPT. Now, in this PPT, you can also be seeing where there we have included, because we cannot now include the data set here. Because the data set, what I have taken is taken, if you have used our software, there is an ISLR package, capital I, capital S, capital L, capital R package. So from that particular package, I have included the data set of stock market, S market. Okay. So I think in Python, how to import the data set from R, you know. So I have imported and done this particular generalized logistic regression where there are more than one cases. Okay. So I have given you in the PPT, it will be there, but we will be not discussing it here because we cannot do. You can go through the PPT and discuss. But for now, I have one task for you. Is that I have a data set with me. So give me a second. So this is the data set I am having with me. Okay, now I'm telling you to perform the logistic regression using Python. You have the codes also with you because when you will be doing this now, then you will be getting to know what difficulty you are facing. Okay. So whether this is visible or the size should be increased. Okay, or else I will be giving you a home task also. You can do it at home. I will be sharing this particular task with you so that because right now maybe some problems may be there, you cannot perform this task here. If you have any problems related to logistic regression, we can do. Or else I will be discussing this particular course now. You can, after this session, you can install the ISI library package in R, and then you can import it to Python. Okay. But for now, I am doing this. You cannot do it with me. You will be having the course with you, but the course will not run. Okay. Because at first we have to import it from the ISLR package in R, and in that particular package, the S market, S, capital S, small MARKT data is there. Okay, so from this we will be performing the generalized logistic regression. So I'll be explaining you what is the meaning of generalized logistic regression. Because up till now we have only completed up to binary logistic regression. So the generalized
Ma'am, could you please repeat that package that you are referring to? Capital S M A R.
ISLR. Okay,
Okay,
let me write it. Okay, here you see what I'm writing. ISLR package
Okay.
in R. Yeah.
Okay,
And
thank you,
here
ma'am.
the data of stock market will be there. SMARKE. So this is the package name. This is the package name, and this is the data set. There will be many data sets, but here we will be using this particular data set. Okay. This data set.
Okay, thank you.
Okay. So, similar to linear regression model, we have extended. Okay, multiple linear regression also we can do. So, in the same way, the generalized linear model, it is a class of models that incorporates binary and polytomous models into this framework, and then applies a transformation to the binary or polytomous variable such that it resembles a variable that is linear. So we have done the binary one, we will be doing now the polytomous. Hence, the generalized linear model can be thought of as a way of linearizing a non-linear model such that it behaves more similarly to a linear model. So for this, what you will be doing this, we will be, as I told you, we will be importing the data set. So from the R package of ISLR, and it is a stock market package. So let me share with you. I have shared with you the code, but of the logistic regression, let us start proceeding. I can explain you this particular part, okay, so that you can, when you have the course with you, after you download the particular data set, you can get go through with this multiple regression problem. So import. So these are the import. What things we need to import? Import pandas as PD. So you by now I think you are clear why we need to import pandas. Import numpy and NP. You also know because all this we have imported in binary logistic regression. Also, we know why the import of the statsmodels.apis SM is important. Okay, now the part comes because here in the binary logistic regression, what we have done is that we have inputted the data ourselves. Okay, but suppose your data is in Excel file. Okay, so what you will be doing? Now this S market data was in .csv form. So we have see here I have kept it in my desktop. It is saved somewhat here as market. Yes, this is the data set. So we can see here, I have kept it in my desktop, and from this only I can call the data set. If it is not been saved, then we cannot call it. So what we have to do, we have to go to Python, and from the import panel, we have upload panel. You have to upload the data set. First, you have to save the data set in desktop, and then you have to go to the upload part, and then you have to upload that particular data set from your desktop. So this is the coding part, how you can do this. pd.read_csv. Why _csv? Because it is in the format CSV. Okay. Index call equal to 0, dates equal to true. So these all are necessary for the upload. You forget about this part, you always write it in this way. Okay. Because here the dates are also included. Okay, the dates need to be included because it is a data series of stock market. And in a stock market, we are always interested with the date. So whether after the G20 meet, if you notice, if you are interested in share market, you could have noticed that the prices of the stocks have gone at that particular day very high. Okay, because of the impact. Also, you can notice during the World Cup, if India is playing, okay, then also and suppose India has win, then the next day the share market will rise. So that is why we are interested with the lag value, because what was that day before up till lag 5 we have considered. So this lag 1 to lag 5 are the corresponding previous trading days. What are trading days they are? Now for each date, the percentage returns for each trading dates are given. You can see here the percentage return for each trading dates are they are given. Now also it is given that the volume in billion of the share traded on the previous day of bidding. Previous day, because leg 2, leg 1 is the previous day. For leg 3, leg 2 is the previous day. And what is the variable today? The variable today is the percentage return on the given date, and direction is the variable. Okay, today. But binary coded into whether the market. So how we can do it in terms of binary? So see, you can see here it is written up, down, up, down. Okay, so that is why when the market was up or down on that given day, we are interested. So now you can see the responses are coming in terms of binary response. It was up, whether it was down. So this direction part is also very important. So now can you tell me, this direction will be, if you write an equation, this direction will be there in your left hand side or right hand side of the equation? Because we are interested in the direction, whether it was the share market was up or down. So what is
Should be on
the
left hand side, binary form, right? Binary form.
binary?
Up for 1 or down for 0, something like that.
Yes. So it will be there in the left hand side. So our function will be in this particular manner. Where it is not here. Direction equal to leg 1 plus leg 2 plus leg 3 plus leg 4 plus leg 5. You can see direction. This is the direction which is equal to leg 1, because up till leg 1 through leg 5 we have considered, and the volume. Okay, we are not considering this today's because upon today's we have given the direction. So we are not taking this variable today. Instead, we are based on this today's decision. We have got the direction, whether the share market have gone up or whether the share market have gone down. You have understood the data set here with the particular data set?
Madam, why we are not considering today?
Why? Because we are not considering, because we want to see whether there was an increase in stock market based on the tradings. Okay. So these are our tradings, leg 1, leg 2, leg 3, leg 4, and leg 5. And what is the variable today? The variable today is the percentage return on the given date. Okay. So it is the percentage return on the given date, and based on that we have written the direction. So you can see 0.959. It is an increasing. Okay, so up. Also it is a positive value. It is up. It is a negative value. So it is down. So that is why we have, based on this today's percentage, we have got the direction. And now we want to see what direction have influence on the different trading days, starting from leg 1 till leg 5 and the volume. That is why we have not considered the variable today. Clear?
Okay.
So
Ma'am, one question regarding this generalized and
Yes.
single. Ma'am, are we considering that in this case we are considering logistic regression model means we are having the correlation or the association between the dependent variables and the independent
Independent variable.
variables can be non-linear type also, right?
Yes, nonlinear type also.
Right,
That is
because
why.
had it been a linear model, we have done the
We
linear model.
linear model. If
Regression
it is
ordinary
a
list.
nonlinear type, then we have to do with the this generalized linear.
Otherwise, if it's a linear model, then we could do on the ordinary least squares or
Ordinary least squares.
yeah,
Yes.
multiple regression model or ordinary.
Ordinary least squares.
Yeah, but one thing is that how do we figure it out or confirm whether the dependent variable and the independent variable are having like which model to go for, like should I go for a linear model or should I go for a non-linear model? How do we actually first ascertain that and then choose our models accordingly? Like, is there any way to confirm that like my this variable can have a non-linear relationship with my this
Yes,
independent
in
variable?
different tests you can see. Okay, there are different statistical tests by which we can see, and then you can confirm whether which one you can take. Now, if there is a dependent variable is a binary, and there is a linear type of trend, you have to see the trend. Okay, then you can go with the logistic or the
Okay.
ordinary list.
That means there are certain tests which we have to do prior and then only we can choose the model.
Yes, yes. Different tests like non-parametric and parametric tests when we are doing, there are different assumptions. So we are not going to the details because whenever you will be doing this generalized linear model or the logistic regression, there are different assumptions. So consider the ordinary list square regression also. Okay, there are different assumptions. So you have to check the different assumptions, then only we can go. So here we are not going to the checking part. I'm only showing you how to do the logistic regression using Python. So for this, you can take a look on any book which is having a brief discussion on logistic regression or brief discussion on or simple linear regression, and can go check the assumptions, different tests which are needed, and then carry on with the analysis. Because I'm restricted to some points. Okay. If I discuss it, then I cannot proceed forward. So that's why I have skipped it. Or else it would be a lengthy one and we have to skip the coding part then.
Ma'am, one last question regarding this. Has it anything to do with this external validity test or reliability test of the data, or it is not related with that? It's something different.
Reliability test, it is not related.
Okay, something different, right? We are actually confirming the validity of the data, whether with the data we have taken, it fits. Okay, okay.
Now, yes, any question more? See, I will not be going. Yes.
Here are the variables volumes, which means what, madam?
The volume of the share traded on the previous day of trading in billions. Okay, like different volumes. Volumes may be what things they have taken, we don't know. So we have the volume data with us. The volume in billions, it is only given of the shares. Okay, volume in billions of the shares traded on the previous day. So these are this particular value. So we have only this thing with us, or we also have note of this particular point that the volume in billions of the shares traded on the previous day of trading. This is given to us. So this particular column is of this particular of that particular value.
Okay, madam. Okay.
We don't have any different other informations I have not gone through. Stock market, if you go through this particular data set in what package I have told, ISLR package, you can see if there is various the brief description of volume, brief discussion on today, brief description on direction. Okay, that we have skipped, and then we have chosen the directly the variable.
Okay.
Only it has been told that the volumes, it is in billions of the shares traded on the previous day of trading. So these are this particular value.
Okay.
Okay. So, so now our equation will be like this: direction leg 1 plus leg 2 plus leg 3 up to leg 5 plus volume. We are not taken the term today, because based on today we have got the direction, and which is our here the dependent variable. Now, to run the logistic model, you will be using the generalized linear model, and will be the family needs to be specified here. But in case of logistic regression, we have seen that the family name did not be mentioned. But here we need to mention the family name. Here we have considered it to be a binomial, but many a times you can go through different books and can see that negative binomial also at a times are considered. So these all you have to go through your data set and have to check and see at which time you will be considering which particular family, whether it will be a binomial family or a negative binomial family, which one. Okay. So now let us go to the coding. Now see, we don't need to import anything more. Here change equal to np dot where. Okay, now this where is like if else condition we are doing in Excel. Sorry, someone please mute off your mic. So this np dot where, it is I've considered it to be a data frame of direction. Now, if you have seen the in the tabular form of direction, the values are in up and down. Okay, so up 1 or otherwise it is 0. That is because I want to represent it, because in the table it is not represented in this manner, or else we have not done it in the form of this particular example, what we have done in terms of binary logistic regression. Okay, likewise we have quoted the different values of 1 and 0, then the values consisting of 1 and the temperature reading. So we need to do this here because we have not written anything, because here how can I know that up is for 1 and down is for 0? So to do this, we need to write this particular code and p dot where df direction, because this direction only 1 and 0 is there. So direction, if it is up, then it is equal to 1. If it is, we don't need to write, because else in Excel also if you see, we don't need to write the term not equal to. Okay, we can simply write down 0. Now this term model underscore constant, it is again a variable name which is equal to sm dot add constant, then df. Df is the data frame. It is leg 1 through leg 5. That is why leg 1, leg 2, leg 3, leg 4, leg 5, and volume. Because you can see here it is not there. It was there in our PPT, because we have taken deduction is equal to leg 1 plus leg 2 up till leg 5 plus your volume. Okay, so to include this constant, we have used this particular form, sm dot add constant, sm dot add constant. Sm dot add constant and the values what will be needing to use it in the constant part. Okay, then the model is equal to your sm dot glm. Why it is glm? Because we are doing it for what? Can you tell me why we have used the term glm?
Generalized linear model.
Generalized linear.
Yes, it is written here down only. Generalized linear model. So since we are using the generalized linear model, so sm.glm is written. Now this package, we have not included any package, because this inclusion of the packages was done here only. Pandas was there, NumPy was done, stat model. So these stat models will be having these different statistical functions. As I have told you in the earlier, when we were discussing in the earlier example, also I have told you what is the necessity of this particular stat model package of Python. Now, what are the things we need to include? We need to include this variable name change, because otherwise we don't know when the value direction need to be included. Based on that only our right hand side will come. Okay, so to include the right hand side term, we have written this change, because change is equal to this direction up or down. Then model constant, it is equal to, what are the terms? Leg 1 through leg 5. Okay, so this particular thing is we have included with model constant. Then family, as I have told you, to run the model, the binary response may be following a different distributions. Maybe sometimes it is following a binomial, it is following negative binomial. So here we have considered the family of distribution to be binomial. Okay, and then fit dot fit will be fitting your particular this GLM model. And then what we have given the variable name as model. It is inclusion of all this, like your equations and the family name and the fitting of the model. And what we need to do, we now need to get the summary of this model. So just if I write down print model.summary and the parenthesis, then it will be giving me the output value. Okay, so this is the output what I have got of the generalized linear model. So we need to interpret the features of the output to here. So from this in this particular example, we know that the dependent variable is direction with categories down and up. Okay, what we are modeling the category up. See, that is why direction is equal to up. That is success. Okay, there is an shared increase. Now, and next one, what we are doing is that the model family binomial and link function logic, we are confirmed that we are working with a logistic regression. So we need to know that why we are working with a logistic. Maybe it is a generalized linear model regression, but we need to know that confirm that it is coming from a binomial family, or and the link function is logic or problem. So we confirm this. So to confirm this, we have got this particular model constant and family Sm dot family is binomial. If it was not fitted with this particular binomial, then certain error would have pop up and given you different values. Okay, then you try with negative binomial or many other cases. If you read statistical books, you can get to know it in detail. Now you can see here the total number of observation in the data file is equal to 1250. The number of observations is equal to 1250. Now, since this is a multiple logistic regression, now it is not a simple binary logistic regression, it is a multiple logistic regression having many predictor variables. Okay, it is imperative to emphasize the interpretation of parameter estimate in the context of the model. Now, if I do with only one leg, okay, now since there are leg 1 through leg 5, now if I consider only the leg 1 here and do the model validation or somewhat in prediction of the model, okay, after this the predicted model part will come. Only if I do with predicted model, then I am giving or I am misleading my audience. Okay, so this all the parameters which I have included in the model should be there. That is, you can see, for example, the coefficient for leg 1 is here minus 0.0731. Now, how can you interpret this? That is, leg 1 is having the value minus 0.0731. We can interpret in this way, that is, for a 1 unit increase in leg 1, we expect on average the logic on the response variable to decrease. Okay, why to decrease? Because the negative sign is there. By how much? By 0.0731 units. Okay, given this is our respective model. Or otherwise said, given the simultaneous inclusion of predictors, leg 2, leg 3, leg 4, leg 5 as well as volume. So with the inclusion of all this model, we will be getting. Now, as in the case in least square regression, it would be somewhat incorrect, okay, to omit a statement about the context of the model. Why? Because the decrease of 0.0731 is not an expected decrease for leg 1. Rather, it is an expected decrease for leg 1 in the context of also including leg 2 through leg 5 as well as volume. Okay. So that is why in this equation it would be always be incorrect to omit the context of this model. We cannot omit the context of the particular model, because if you are not included the other parameters like 2 through like 5 and volume, then you will be misleading your audience. Okay, so all models are context dependent. You must include the context of the model you ran when interpreting the individual coefficients, because every things need to be defined, like 1, like 2, like 3, like 4. Now you can see the above are in units of the logic. So these are all your log values, okay, or the log odds, you can say. So now you may prefer to interpret things in terms of odds. So how to get this? That is, to get the odds for each predictor, we have to what to do? We have to exponentiate the logic. So how can we do? We have here the code with us. So this is the value. Now it is not in the log dots, but in the simply odds. Okay. So the exponentiated form is 0.9295. So this is a simple example which I have taken for leg 1, holding all other variables in the model constant. Okay. By this, what I mean, that is holding all other variables in the model constant. That is giving the context of the model. I have taken this particular values to be constant, because an odds of 1 represents even odds. The number 0.92595 represents a decrease. So that is for a 1 unit increase in leg 1, the likelihood, I can say, the likelihood of the even decrease of the event decreases. Okay. Now, similarly, you can calculate the different values, log values of with simple log by taking replacing this particular value -0.031, that is for leg 2. We can take it -0.0423 and can get the value and can interpret but in your own writing up till the volume part. Okay. So this was all based on logistic regression, multiple logistic regression. The multiple regression I have not got into the details because it is a big clumsy one. The families are also included. So I have chosen only the binomial one and shown a simple example. You will be getting different.
Madam, what is the value we did? What is the value we got it? 0.92. How to interpret it?
Yes, you need, because we are getting it logarithm values. Okay, these are your all log dots. What you need now, the odds value. So if you take the exponentiate term of this value, then you will be getting the odds value. So first, what you have to do, you have to import this particular package. Import numpy as np. Then np dot exponential of this value you will be getting. You need the exponential of this particular value 0.0731.
Okay, exponential.
Yes, exponential.
Okay.
EXP stands for
Okay, EXP exponential. Okay.
exponential.
Okay, thank you.
Okay, so this was all about today's session. I think you all have understood a bit. I will not be telling that you all have understood it to a full extent, because understanding logistic regression and then doing the codes using Python is a bit difficult in one class. We need to practice, and the practice still, I will be saying I am also not perfect. We work with different set of examples. and we clear our doubts. Okay, so thank you all very much for a patient listening.
Ma'am, I had one request.
Yes, yes.
Ma'am, can I